Welcome. In today's video, we're going to be talking about the new IBM PowerHA SystemMirror offering for Linux that was released in 2017. The intent of this video is to show the new integration that we have with SAP HANA and then the PowerHA SystemMirror software. Um, there are a couple instructional videos from the PowerHA side of the house, little short how-to videos that show a little 2-minute glimpse as far as how you can apply the policy. But in this particular recording, what I thought I would do is actually show you the deploy of the cluster software from the ground up. So if you know how SAP HANA System Replication takes place, you effectively would have two separate VMs or two separate LPARs. Each one is going to be hosting a database instance. So I might have System 1 and System 2, and then you're going to leverage the HANA System Replication. And there's different modes in which they support the replication. So you've got, synchronous, asynchronous. What we need, if we're going to go ahead and cluster this particular piece, instead of leveraging the HA extensions, for example, with SUSE or RHEL, we'll need a virtual IP name, and then that way the outside client connections will be communicating with that IP. And in the event that access to the database instance has to switch from one side to the other side, that virtual IP connection will need to actually switch. So what we would need is some type of cluster software to move that virtual IP address and also to manipulate the system replication. So in this particular video, we're going to go ahead and take a look at the PowerHA SystemMirror software. It's version 7.2.2, which lines up with the AIX offering, but this is a Linux specific offering. It's supported on SLES 12, SP1 and above. The particular demonstration that I'm going to do is leveraging SP3. And then on RHEL, we support it on 7.2, 7.3, 7.4. I suspect 7.5 support is going to be coming in the near future. But this kind of gives you a picture as to what we're going to be playing with. In our lab environment, the way that we went about this is we went ahead and we deployed two VMs. You see the 61 VM on the top left. The 62 VM will be the partner cluster member. They are both running SLES 12 Service Pack 3. And then I happen to have some data volumes in place. I have a dedicated disk for a disk heartbeat device for the cluster software. I could have probably used a partition if I had a shared volume other than that disk heartbeat device, but since in the HANA environment, the data volume instances are going to be independent of each other, I went ahead and I provisioned a couple of shared disks. One of them is going to happen to be a disk heartbeat device. And then we did go ahead and configure an NFS back tiebreaker. The second shared disk that I deployed in the environment, I could have used a disk backed tiebreaker device. My preference would probably be NFS. It seems a little bit more resilient in this type of configuration, and especially if I'm already effectively taking advantage of a shared disk heartbeat device on the bottom. So we're going to go ahead and install the PowerHA software on those VMs. I've already got the packages there. I'll show you the actual installation process and then the cluster configuration. And what it'll do is once I configure the cluster and apply that SAP HANA specific policy, it'll automatically create resource groups and start manipulating the HANA system replication. So that's the goal for today. If I were to look at the shared disk configuration, I don't have to have a minimum size of 10 gigs for that disk heartbeat device. That could have easily been a 1 gig disk or some type of quorum disk that's tiny. I really only need a small area on that volume. This particular one just happens to be a 10 gig volume. I did have a second one configured that's actually shared between the two cluster members, so I could play around with a disk-backed tiebreaker device. That's not how I'm going to go ahead and configure this particular one, even though I could choose option 1 or option B for the tiebreaker. And then the data volumes. There happens to be a 100 gig disk on the left hand side for the OS. I have a 300 gig shared disk for that HANA database. And then I have, the same thing on the 62 VM where I've got an OS LUN and then the HANA database LUN on the second side. Beyond this, the PowerHA for Linux offering is command line only in revision 1 as far as the configuration. But as far as the management, not only can you manage it via the CLI, but we also have a new UI server configuration that also manages AIX clusters. So that same front end could be used for Linux and for AIX. So what I went ahead and did is on the top right for the 63 VM, he's also running SLES. he happens to be the SAP S4 application server VM. I went ahead and I loaded the UI server code on it. I could have set up any other VM outside, whether it was AIX backed or whether it was Linux backed. But that's where my UI server is running. That's the one that I'll be connecting to go ahead and get access to that new PowerHA GUI that will let me do the administration of that SLES PowerHA cluster that I'm configuring. That guy is not a cluster member. He's effectively only going to be running the UI server code. And I'll show you the installation of that as well, so you get a feel for how long it takes. At the tail end of the session, I'll also have a couple, things to look out for, like I have in previous recordings when I discussed other line items within PowerHA. Okay. So now that you've seen what the actual logical configuration looks like, you know that we're going to be playing with 3 VMs, Node 61 and 62, which will effectively be the 2 cluster HANA members, and then Node 63, which will get installed shortly as my UI server node. So for starters, let's go ahead and take a quick peek at my version or my release. And you'll see that I'm playing with SLES 12 Service Pack 3. I've already downloaded the PowerHA package, so I've got them in a common path between all my cluster members. And if you look, this comes in as a compressed package. I've already gone ahead and untarred it, and then that PowerHA Linux 64 directory got created. So if I go ahead and I enter the directory, and I do a quick peek in there, you'll see that I've got sample scripts, I've got the README file. The main component is going to be that installation script. So this is different than the way that it works on AIX. On AIX, I would leverage SMIT or the install p command and install individual packages. Here, what I can do is invoke that install PowerHA script, and it'll go ahead and install my PowerHA packages and my RSCT packages in one shot. It's going to first prompt me to accept the license agreement, and I'll spare you the details and just kind of skip ahead to the end. And let me go ahead and continue parsing through. But once I get to the end, I'll just type yes, proceed, and you'll see that the installation is pretty hands-off. Once it completes, it'll leave the RSCT daemons running that it actually needs. So it's almost complete. And I do have to go ahead and perform that operation on both nodes. So I just did it on node 61. I would go ahead and do the same exact thing on node 62. Now what this did, if I take a look at the actual packages, I can do an rpm-qa grep for PowerHA. You'll see what it actually installed. Same thing for RSCT. And one of the things that it does not actually do is it does not install the agent code that you need to be able to handshake with a UI server node. So to be able to play with the GUI, you want to go ahead and install that. So if I go back and I display the contents of that directory that got created, you'll see that the very first thing up top is that GUI directory. So if I enter and I display the contents, you'll see that there's a separate install PowerHA GUI script. So let's go ahead and run that, but we are going to be conscious of the flags that we run. Here I'm going to do a -A for the agent and a -C for the common package. And again, that'll go ahead and pull in the components that I need to be able to play with that GUI. It should only take it a few seconds. And even though you see them right there, if I was checking for the SMUI code, you would see that I've got the agent and common packages in place. I've already kind of skipped ahead and I've done the installation on node 62. So just to kind of show you the gist and spare you, accepting the license agreement one more time, I've already got RSCT, I've got the PowerHA code, and finally I've got the SMUI packages installed there as well. Once I've got that piece configured, I can go ahead and proceed with the cluster configuration, or if I wanted to, I could go to node 63 and install the code that I need for the UI server. That one's easy enough because if I look at the contents of the directory, I have the whole bundle or package specific for the PowerHA code, but this guy's not a cluster member. So here, I'm simply going to install the contents of the GUI packages themselves. So here I will run an install PowerHA GUI, but here I do want to install the server code and the common package. And if I let this guy kind of go through, you'll see that here he is actually creating private keys. This guy's going to be an actual web server. It's going to automatically provision everything that it needs. And if I do an rpm-qa grep for the SMUI, here you'll see that I have the server and the common package. But in turn, if I just show you the PowerHA pieces, I did not go ahead and run the installation script for the PowerHA or the RCT components. Now there's a separate configuration script that I want to invoke to launch that web server. That particular one is located down a different path. So if you go, let's see, into user es sben cluster UI server bin, what you'll see in here is that SMUI configuration script. So I actually want to run this guy, and when I invoke him, he'll go ahead and do the prep that he needs. Check for any prereqs that he actually needs. Notice that he's checking for libraries and getting everything bundled and packaged for you. And then notice that we were playing with the 63 IP address. This is how I would connect to the actual GUI server itself. We'll be going there in a little while and registering the cluster that we're going to go ahead and configure now. So I'll switch gears and go back to the cluster members, define the cluster, and once I have an existing cluster, then I'll show you the GUI. When we log into the GUI itself, you'll see that he's going to be empty and not have visibility into anything. So we'll go ahead and we'll discover the cluster, which should only take a few seconds. So now that we actually went through the installation of the files on both Node 1, Node 2, and the VM Node 3 for the UI server, let me go ahead and collapse it down to just simply the two cluster members. So to go ahead and get the cluster configured, the assumption is that we have a couple config files in place. So just like you would on AIX, we're going to go ahead and take a look at the etc cluster rhost file. I went ahead and I populated it with the base IP address for the node on the left and the base IP address for the node on the right. The files are identical on both sides. And I went ahead and I already keyed in these files. You guys don't need me seeing doing the actual VI operation. If I take a look at the etc host file, I went ahead and I simplified the file so it's relatively easy to read. I've got my two base IP addresses, the 61 and 62. I've got the floater IP address or the service IP, which is the 200. And then you'll see an entry in there, the 63, which is my actual UI server. In your environments, you may have a ton of entries. So just as a heads up, I made sure that my file was appended and identical on both sides. The final file, just like I would have on an AIX cluster, the netmon.cf file, I did go ahead and configure him. I only put a single IP address, even though you can actually have many in there. But the path for the Linux configuration is different than on AIX. So if you look at the var ct config netmon.cf file, this is a file that you would go ahead and define, and I simply put my default gateway in there. And the file again is identical on both of the nodes. So I went ahead and I populated it so that the cluster, in the event of some type of network outage, will go ahead and try to pull outside to determine whether the failure is local or what's somewhere out there globally with the network. So now that I've got those guys in place, I can go ahead and create the cluster configuration. And this part's relatively straightforward. Right now, no cluster exists, but just simply the file sets are in place. So I can do seal manager, create cluster. Let's go ahead and give him a name. So we'll call him SLES HANA PHA cluster, just for simplicity's sake. And we'll define the nodes, ATSSG 61, and we'll go ATSSG 62. Oh, and I've got a typo. Again, hence why I spared you my VI skills. I'll go ahead and I'll create the cluster. This should take a few seconds. And iteration 1 of the Linux cluster, most of the deploy is going to be done via CLI. If you choose to leverage the UI server, there is a configuration wizard that you can go through and do the deploy. Today, it does not have the Smart Assist configuration wizard for the SAP HANA integration, but that should be coming in the very near future. I've already seen screenshots. It's just not G8 yet. So just be mindful. My cluster was not created. I did it from one of the nodes. I could have done it from 62 or 61. But now that the cluster is in place, just like I had shown in the diagram previously, I'm going to go ahead and define a disk heartbeat network. So if I take a look at the shared disks in the actual environment, I should have two shared volumes like I had described earlier, and then I have two that are local to the machine. So if I take a look on the left side and on the right side, you'll see that the 2D4 ID is common between the two sides and also the 2D5. So there were two 10 gig volumes that I had defined in the environment. The other guys are completely separate. So I have one, the OS volume, one for SAP HANA in a real life environment. I might have multiple physical volumes defined there. But this is a relatively simple configuration. If I invoke the command and instead pipe it into a page or more, you'll basically see the details. So you'll see that that 2D4 happens to be a 10 gig volume, and you'll see the various paths that are actually available for it. So I'm going to go ahead and leverage that shared disk and use him as my disk heartbeat device. So the command is simple: seal manager add network, DHB network. And one last thing, I guess, before I invoke the command, one of the things that you do want to see is not the fact that it's just a shared disk, but we're actually going to use the UUID of that particular physical volume. Now, in order to see the UUID, I had to create a VG. So I did go ahead and already do that. Here you see my 2D4 ID, and you'll see that I created a volume group called DHB VG just to kind of keep up with whatever it is I was doing. I didn't want to have any confusion and have to really just go based on the names. But that UUID right here is the one that I'll actually be using. And as long as I see that on both sides, so if I do a display, you'll see the same exact one, 2D4. You'll see my local volumes up on top, but it's the same UUID visible on the left side and on the right side. So let me go ahead and create the disk heartbeat device. Add network, and we'll go DHB network and type equals disk. That PVID, I'm definitely not typing that one. And let's go ahead and paste them. And then my nodes, which are ATSSG61 and ATSSG62. So this will go ahead and effectively create my disk heartbeat device. That was pretty straightforward. The last piece is right now, if I do a seal manager query cluster, I don't have any NFS tiebreaker or split policies in place. So I'm going to go ahead and define that next. I mentioned that I was going to leverage an NFS server that was external to my cluster members. I could have used the second shared disk device and used a disk-backed tiebreaker device. I would probably prefer, since I'm already leveraging disk heartbeating, to use the external space. So the command that I'm actually going to use is seal manager modify cluster split policy equals tiebreaker, and then tiebreaker will be type NFS, and my NFS server, this guy happens to have a different IP address, 9.30.175.38, and my NFS server mount point, he is going to be /repo/NFS tiebreaker for Mike, so it's easily identifiable on my end. And my local mount point, let's go ahead and make him, I already created the directory, mnt NFS tiebreaker, and I'll need an NFS file. So let's go ahead and give him a name, and I did not create this file. The command should be creating this for me. Tiebreaker.sh. So this should take a few seconds, and if it's able to go ahead and establish that NFS mount, it'll add my NFS tiebreaker. And if I simply query the cluster, I'll now have the information visible. So there's your example. This is an NFS tiebreaker device. You'll see the information that I just defined, and my split policy is set to tiebreaker. The device info would be populated if I was using a disk-backed tiebreaker device. So beyond this particular piece, now I've kind of gone through the hard part. I can simply go ahead and start up cluster services. Seal Manager start cluster. And there are no resource groups or anything created yet. The nice thing is that with the PowerHA for Linux offering, since it has that direct integration with SAP HANA, I'll go ahead and I'll run the actual Smart Assist configuration wizard. So I did the tough part now. I'll just invoke the Smart Assistant. So if I do a Seal Manager setup, Smart Assist, and then the application is going to be equal to SAP HANA, and SID is going to be HN4. My instance equal HDB 00, and the mode equals new. And it is case sensitive, so be conscious of that. So if I invoke this, it should go ahead and harvest the information that's actually out there. So that was as simple as invoking the Smart Assist wizard. Again, phase 1 or release 1 is going to be command line only. This will effectively become a wizard through the user interface that you'll be able to just kind of select the options you want, click one push, and go through the motions, and it'll go ahead and do the deploy for you. So it's missing the information. So what you'll see is if I select option 1, it's already identified the cluster definition, so I can just go next. So 3, proceed. It's looking for the nodes that I want to use. It's already harvested that information, so you see nodes 61 and 62. So I can just go ahead and go next. And then now it's asking me for the actual IP address. So here I am going to have to enter a value. And if you saw it earlier, it was 9.30.175.200 actually. And once I've got that in there, I'll go next. I'll take the default net mask. I know that that's valid in my environment. And now it's asking, hey, what interface do you want to use? I've only got one configured, so I'm going to go ahead and type it in. Ethernet 0. It's in place. It went ahead and detected the SAP instance. So you see HN4 ADM, and I can just go next. And finally, the currently defined value. It's already pre-selected, so just 3. Go through the motions. And it's just kind of doing a sanity check. These are all the different values. Now it's displaying the sites. Those again were defined during the actual HANA configuration. I can go next. It's detecting the fact that it's doing sync mem as far as the replication type. And actually, I'm pretty much there. I can go ahead and finish. If I want to go ahead and activate this, I can go ahead and do so by selecting the option 2 to go ahead and update currently active policy. I don't have one there, so I'm just going to say yes. Go ahead and activate it, and yes, I'm going to agree to that. Now this should take a few seconds, but the nice thing about the guided wizard is that it's going to go ahead and automatically detect everything that we just went through. It's going to create resource groups and dependencies for it, and I haven't had to type any type of scripts or anything. I did go ahead and populate the shared service IP address and the etc host file. It's going to use that as the floater IP address, and it's going to take care of the movement for a planned or unplanned outage automatically. So when this completes, what I should see is that my resource groups are created, but everything is actually going to be in the offline state. So I'll be able to go ahead and start up the resource groups, which would effectively start up the HANA replication for me. Now it's been pre-configured. I had previously stopped things, but when I go ahead and apply the policy, it's just going to go ahead and handshake, start things up. And what I'll do is I'll hop into HANA Studio, and I'll show you not only the version of HANA, but I'll show you the fact that the replication is actually in place. And then we'll do an actual failover and discovery through the UI server. So now that it's actually gone through the motions, you'll see that the policy is now active in the domain. No additional actions are required. And if I do a CLRG info, again, one of the older legacy commands on the AIX side of the house, but you'll see that it automatically went ahead and selected the resource group names for me. It's got a common one that'll show up on 61 and 62, and then it's got one for the primary instance and one for the secondary instance, but everything's offline. So in order to go ahead and activate things and get things going, line RG all. So just go ahead and process everything. This will take a little bit because it's effectively starting up the HANA replication and making sure that everything is in sync and working in an okay state. So I'll let that guy go along. In a second, I'll run the CLRG info, and what you'll see that it's actually processing, but it'll show an online pending state. So it'll take a little bit of time. Now we could monitor things from the HANA side of the house, but just to show you a few things in the meantime before I go ahead and I hop over to the HANA Studio, here's where you'll see the intermediary states. So it automatically went ahead and took care of the actual database processes, but then now for the primary and the secondary instance, it's establishing the replication. So that's where you see the pending online, and then you'll see the different states on the secondary side. So it's processing. It's going to take a little bit of time. I did all of the configuration from node 1. Unlike on AIX, I didn't have to do any type of verify and sync operation. It automatically went ahead and propagated all of the configuration information from node 1 to node 2. So the same exact set of things or line items that I saw on the left-hand side, I will see on the right-hand side. So that was pretty much the entire config. That was the tough part. Within the next couple of minutes, what you'll see is everything will be in the online state. So I'll probably pause the recording, just kind of skip ahead to the when everything is in the actual online state, and I'll also go ahead and discover the cluster through the user interface, which will make it a little bit more exciting as far as what you see on the screen. Well, I was letting the resource groups actually come online, and it only took maybe a handful of minutes. I went ahead and I waited for things to come all the way up. So now that I do a CLRG info, you'll see that it's online, the primary instance, the secondary is actually online, meaning that the replication's all the way up. Not quite as exciting seeing it from the command line interface because you don't get all the details that you would when you're looking at it from the HANA side of the house. So we'll do that in just a second. We'll launch HANA Studio. But here you see that the application Smart Assist went ahead and configured all of those resources for you. So CLRG info will show you the current status. The reason I separated out my windows for this particular section of the video, you can do things like CLRG info-E, and you'll see it's a little bit easier to expand when I separate out the windows. All of the different resource groups and the various dependencies that actually got configured by that Smart Assist. So if I did something like seal manager query, if I type it right, dependency, you'll see that there's a number of different dependencies that got automatically established. The whole process was very hands-off. I can do things like if I do an ifconfig -a, you can see that my service IP address is actually online. I've got my base and the service IP, the floater effectively that goes back and forth. If I do a seal manager query RG for my resource groups, these are the 3 RGs that got created. If I invoke the same command, but I do the detailed seal manager query resource group, so if I do the verbose option, you'll effectively see the various details that actually got created automatically. So there's a nice value add of having that Smart Assist in place because it set up every single one of those dependencies and policies to move from one side to the other side. I can run other seal manager variations of the command. So if I did things like seal manager query service IP, you'll see the service IP address that got created. If I do the same thing, but instead I tag along the IP address name, so this is not the label that was in my Etsy host. This is what the wizard actually defined for me. I should be able to get more details about it. So there's my service IP that floats back and forth. I can do the same thing if I do a seal manager query network. You'll see the various networks that are actually in place. Notice that I've got a disk heartbeat network and the one that it created to move the service IP address back and forth. And like I did in the previous command, if I just recall it and I give it the actual network name, if I captured the whole thing, you would see the details for that particular network. I've already shown you the dependencies. The other things that come into mind is that since we're using components like RSET that got automatically installed, you can do things like an LSSRC minus LS on, let's see, CT hats, and the type of information that you see here. You can see the heartbeating that's taken place between node 1 and node 2, any missed heartbeats. You also see the disk heartbeat network, the fact that it's actually up and stable. So this is some of the stuff that you might equate to some of the AIX flavors when you were running things like seal top info and variations of the PowerHA software for AIX. So again, you get a bunch of different operands. Most of them are preceded with that seal manager command. So if you kind of scan through the seal manager man page, you'll see that there's a whole bunch of things that you can actually do from there. Let me go ahead and connect to HANA Studio real quick, and I'll show you the primary instance is currently hosted on 61, so that's the one that we'll be connecting to. And once I'm here, you'll notice that I had already predefined 61 and 62. Let me go ahead and click into it and establish the connection, and he should be telling me that the replication is actually okay. So the activation of the cluster software went ahead and took care of that piece for me. I'll show you the mode that it's running on in the version of HANA. So here we're playing with HANA 2.0, and you can see that we're on SLES 12 SP3. Right above it, you see the version. It's running version 2.0 of HANA. And as far as the system replication, all of the services are active and in sync. And if I click into get the actual details, you'll see that the replication mode is set to sync mem. Beyond this particular piece, I mentioned that it was probably a little bit more exciting to browse this through the user interface itself. So let's go ahead and connect to that UI server. Oops, 9.30, that's 175, and this one was 63. And if I connect for the first time to that UI server, it should be, prompting me, letting me know, hey, this is something new. Do you want to go ahead and confirm that security exception? But it launched the web server earlier. My browser's already stored some of that information, so it's got the pre-can, default user that I can log in as. When I log in for the first time, it should not be aware of any clusters whatsoever. So you get this view. If I now want to go ahead and add a cluster to the environment, I can go ahead and go through. I want to add an existing, and the wizard that I mentioned, we did everything via CLI before, that you could go through is right here. You could create a new cluster this way as well. I opted to go the command line path. 175, and we'll go ahead and just establish the connection to node 61, the first node. I could just as easily do node 62. And again, my browser stored some of the password information and user information. So I'll just go ahead and discover the cluster. And this should take just a couple of seconds. You'll see the cluster definition that we created earlier telling us that it's running 7.2.2 fixpack 0. And when I exit out of here, it'll start gathering all of the information, give me the view into the actual dashboard. This is the first cluster in the actual environment. So 2 nodes, it's got the 3 different resource groups. And one of the observations that I picked up on, I have other UI servers in place where I manage AIX and Linux clusters. And there I tend to see events on the bottom that are there from the previous sets of activity that took place. On Linux, it's a little bit different. So the first time that you actually go in, you'll see no activity. As soon as I initiate an operation, it'll almost work like tailing an HACMP that out file. So you'll see the events actually getting populated at the bottom. And then you'll also see the dynamic events load up and that timeline in the center. But from this view, and again, the reason that I made the screen a little bit larger and I kind of left everything zoomed further out was so that you could see when we discovered the cluster, it picked up the 2 nodes. It says that everything is online. But if I expanded, node 61 is currently hosting that primary resource group or the primary HANA instance. And then node 62 has got the secondary. So again, the resource group managing those components. If I wanted to go ahead and get some information about the cluster, I can go ahead and get limited information through this particular front end. I do have visibility to the cluster logs themselves, and then obviously the events. If I was going to initiate a movement operation, if this was a soft move, I wanted to relocate the primary instance from one side to the other side, I can go ahead and easily do it through the command line with a seal manager operation, or I can just simply move the resource group from the user interface, and I can say, hey, go ahead and move me to node 62, and he'll tee it off, and what you'll see is he'll actually go offline. You should be seeing some events actually get populated on the bottom, reporting that there is some activity taking place. And the same type of information that I'm seeing here, I should also be losing my connection through HANA Studio, so I'm going to go ahead and kill him, and I'm going to go back to my terminal windows as well so that I can monitor through the command line interface as well. But you'll see that there's activity already taking place through the user interface. You see that there's an RG move operation taking place, which should be taking the primary actually offline there. And then if I did a colrg info through the command line, you'll see the relocation of the resources, and it'll reestablish the replication going from node 62 over to node 61. So right now you see that the secondary is online on 62. That should be flipping. And I could write a little wrapper script and get the colrg info kind of probing every few seconds. I'm just kind of going back and forth and monitoring it this way. But on the bottom, you can see that it's showing the primary resource group. The primary is pending online in node 62, and this is where the mileage will vary as far as the size of the database. So you kind of have to, sit tight and wait. But you'll see the various events actually getting logged. If I do one more check, let's see where he stands at. And you'll see that he should be just about completed. Node 62 is now hosting the primary resource group. He has not finished setting up 61 as the secondary. He's still in the process of taking care of that piece, but we should be seeing it on both fronts. And now that the IP address is actually online on the 62 node, if I do an ifconfig, if I could type, I'm going to say I should already be seeing the 200 IP address here. That should have taken place almost instantly. I should be able to connect to the 62 node and monitor through HANA Studio as well. So while this actually launches, we'll get that same screen that we had before. We'll be able to see the status of the actual replication. And then we should get to the point that we see the secondary resource group on one side and then the primary on the opposite side. Currently, all services are active but not in sync yet. This will be transitioning into the actual sync state. And again, system replication, sync mem, it's now going from 62 to 61. So it did go ahead and automatically redirect the replication. And it's not quite ready to go ahead and perform any activity. But now you see 61 is online. If we come back in, click back on the overview tab, see if we can actually get it. All services are active but not quite in sync, so it takes a little bit of time, but the resource groups did go ahead and get relocated, and we're effectively back to the state that we started. Some of the other things that you can do is you can come in and you can create zones through the user interface. So if you had a number of clusters, whether they be Linux, SLES, or RHEL, managing SAP HANA instances, whether they were AIX clusters, that same user interface can manage a number of different clusters. So one of the benefits here is I could create a SLES cluster zone, prod HANA clusters. If I continue, and this is just a grouping, so there's only one cluster in this particular instance. I literally defined the cluster from the ground up and the UI server. Now that that definition is in place, when I go to the main screen, I should effectively get a grouping. So I see that there's one cluster there. This is kind of a dashboard here. I also see the health summary up on top. And when I expand, I should be seeing the HANA cluster, the nodes are both actually online. I should see that my resource groups have been flipped. So notice that 61 has got the secondary instance and that 62 has the primary instance. So it was as simple as that. I could have, again, done it via command line with a seal manager, move RG, given it the primary resource group name, and then I could have done node equals ATSSG 61 now, being that he's actually hosted on 62. So the operation can be done through the UI server or through the command line. The whole point here is actually simplicity. So if I finally flip back and just show you the summary of what we did, I showed you the configuration files on node 1 and node 2. So the etc cluster rhost, the etc host file, the netmon.cf. I showed you the installation of the base code and then the agent and common file sets on both of the cluster members. From one of the cluster members, these are the steps that I used to go ahead and create my cluster and launch the Smart Assist wizard. And then on the UI server, I went ahead and I installed the common and server packages, and I ran that SMU installation configuration script. So this is just kind of giving you a short summary as far as the steps that we took. Finally, as far as the deployment tips, there are a few things. So when I did the initial installation, my SLES build did not have the KSH package in place. It was in one of the legacy repositories, so kind of be conscious of that. The installation script wouldn't work. I did go ahead and disable the firewall on both of the nodes. If you don't disable it in its entirety, being that it's not a lab environment, you may want to go ahead and open up certain firewall ports. They are documented in the pubs. You've got them here as well. And then in order to get the UI server to go ahead and register the cluster members, I did have to make a slight modification on the nodes themselves and on the UI server. So in the etc ssh underscore config file, there's a password authentication that's actually set to no. I went ahead and I tweaked that to yes. And in order for that change to take effect, I ran the systemctl stop for sshd and restarted it, or I ran the rcsshd restart command. The last one, and this wasn't actually a HANA tech note, but this one in the etc system.com file, there's a default tasks max set to 512 that's actually commented out. The recommendation from their end is to go ahead and tweak this to 65,535 and then reload your daemons. So once I did that, that goes all the way up, I believe, for SLES SP3. I believe the upcoming revision of PowerHA will go ahead and make a modification to circumvent that as one of the requirements. But there's a number of tips and recommendations that I picked up on from the actual deploy. Hopefully it was relatively straightforward to follow, and you see some of the value adds that you get by leveraging not only the UI server but the PowerHA software as far as managing the SAP HANA instances. Thanks for watching. I'll finally thank Damir Rubik on my team that helped me actually do some of the deployment of the VMs and provision the HANA instances. And again, thanks for watching.